Hello, my name is Vegard and I will take you through this video. In this video I will talk a little about binary counters and explain how to program both universal binary counters and mod-m binary counters. After you have watched this video, you will be able to write VHDL description for regular sequential circuits, meaning universal binary counters and mod-m counters. First of all, I would like to explain what a universal binary counter is. A universal binary counter can count up or down, it can pause, be loaded with a specific value, or be synchronously cleared. We can start looking at the code, and what we see here is that we have some packages. These packages is very important. By including these packages, we can use certain arithmetic functions for vectors and other functions in our program. Then we can move down to the entity scope. In this entity, we have declared all the inputs and the outputs. We also declare a generic function with integer n that we use in both the d and q, the vector. To show the size of the vector, in this case both of them are 8-bit, going down from 0 to 1. The reason it's 8-bit is because we have set the n integer to 8, and the reason it's 7 to 1 is 8 minus 1 down to 0. This counter can count up, down, and do a synchronous clear. That means that there exist two ways of resetting the output. Either we can set the synchronous reset to 1, as shown in the register. The other way is to use the synchronous clear signal and set it to 1. When this is set to 1, the next state will take all zeros, meaning it's reset. In the next line after that, we can set the load to 1. And when the load is set to 1, it will take the input of D. This will depend on whatever the user decides that the D should be. The next two lines simply tells us that we can add and subtract in the register. The output logic tells us what will come out of the program, and as we can see, when we reach the maximum number, the max tick will show us 1, and when we are at 0, the min tick will show us 1. This is to make it easier to tell what will come out of the next state. If we example are at the maximum number, which is 1111, 1111, the next state should start at 0000, 0000. Now I will talk a little bit about the mod-m binary counter. A mod-m counter counts from 0 to m minus 1. M specifies the limit and n specifies the number of bits needed. Instead of going through the whole number, let's say we have 4 bits and can count to a 15 at maximum, modulus makes it possible to stop at whatever number we want. If we want to stop counting at 5, we have to have a modulus 6 counter, since the formula is 0 to m minus 1. The state register will be the same as in the universal binary register, but the next state logic will be a bit different, since it will only count upwards until it reaches the limit m that we have written. If it doesn't reach any limit, it will keep counting upwards until all the bits have turned 1. When this happens, it will start counting again from 0. And that was all I had to show you this time. Hope you enjoyed. Thank you very much for your attention.